So inductive reasoning is where you make a prediction on what's going to happen based on what you've seen in the past. Is it always right? No, but it's kind of like an educated guess. That's inductive reasoning. Deductive reasoning is if you know the rules, like if this is true and this is true, this has to be true. So, what's an example? I think the example I used when we learned inductive was, if the animal's a dog, it will go to heaven. Fido's a dog, therefore Fido goes to heaven. So that's deductive reasoning. Here's the rules. The animal's a dog, goes to heaven. This animal's a dog, therefore it goes to heaven. So that's deductive reasoning. If this is true and this is true, this has to be true. Not a guess. Okay. Now, sometimes your premises are false, so your conclusion might be true. This is a premise is like you're saying these are like the things we're just saying are true, like dogs go to heaven. Now, is that a true premise? I don't know, but the plural is premises. Anyways, those are like the things we are assuming to be true. Okay, very good, Alex. And if they are false, your conclusion will be false. Okay, so there's three kinds of deductive logic. Let's start with, actually before I do that, let's go back to yesterday for a second. Okay, what's this arrow mean? It means if A, then B. So A implies B. If A happens, B will happen. And remember the squiggly means not A. So what is the converse of this statement? How did we do converse? It's one we just graded. Huh?
Switch the wording.
Yeah, if B then A. How about inverse? What does inverse do?
You change it and make them negative?
Yeah, negate both of them. So back to the original. So it's if not A, whoops, then not B. Okay, and then the contrapositive is where you do both. You switch the order and negate. So it would be if not B, then not A. Whoops. Not B, not A. Alright, that was from yesterday. So today, let's start with the most basic logic. And yeah, let's start with that one. Okay, so if A then B, then A happens, therefore what's going to happen right after that? B. Okay, this little triangle dots means therefore. So this means if A happens, B will happen. A happened, B happens. Okay, I know this seems silly. Let me make an example. This is the most basic one. It's called modus ponens. I believe it's like Latin. That's why it sounds weird. Modus ponens is a kind of logic. Let me think of an example. Let's say if it's the weekend, I'm going to go to the store. Today is Saturday, therefore what? Okay, if it's the weekend, I'm going to go to the store. Today is Saturday, therefore what? I'm going to the store. Okay, that sounds really basic and kind of that's kind of what modus ponens is. It's kind of just stating the conditional statement. If it's a weekend, I'm going to go to the store. It is a weekend, therefore I'm going to the store. So that's called modus ponens. Okay, the other one, so I'll use that same example. Let's say it's not the weekend, like let's say it's Friday. So if it's the weekend, I'm going to go to the store, but today is Friday, so it's not the weekend. Therefore, what can I conclude from that? I'm not going to the store. Okay? This is basically the contrapositive logic. If this doesn't happen, then that means this didn't happen. Because if A happens, then B will happen. So if B didn't happen, there's no way A happened. Okay, this is called modus tollens logic. Modus tollens. Alright, does that make sense? I know these symbols are kind of weird, not used to it, but so modus ponens, the way I kind of remember this is it's kind of in alphabetical order, like P comes before T, ponens before tollens. And like basic comes before more complex. So yeah, this is kind of like the contrapositive, not B then not A. It's basically what this is saying. Okay, and then the last one is if A happens, then B happens. And then if B happens, then C happens. Therefore, what can we conclude from that? You guys know? If A, then B. And if B, then C. Therefore, what? Right. If A happens, C is going to happen. Because if A implies B and B implies C, therefore A implies C. So an example of this is, let's say if it's Saturday, my grandma's gonna bake cookies. If my grandma bakes cookies, then I'm gonna eat them. I'm gonna eat cookies. So therefore, what can we conclude?
On Saturday, you're gonna eat cookies.
Right, if it's Saturday, I'm eating cookies. So yeah, this is called transitivity. This word will stick with us through the years. Well, the others will not really see them again, but transitivity. Okay, the way that I remember this one is this kind of looks like train, and A is connected to B and B is connected to C, like train carts. Does that make sense? And therefore A and C are connected because they're on the same train. All right. Anyway, that's transitivity. That word will show up a lot this year. These other two, not so much. This just kind of logic. We kind of know this stuff instinctually. Just this makes sense to us, and this is how it works. So those three. Is there anything else? I feel like I'm forgetting something. Maybe not. Yeah, I guess that's it. Not a lot. Okay, so on 1 through 6, we're saying whether this is inductive reasoning or deductive reasoning. Do you guys remember what I said inductive reasoning was? Hunter, arise.
Okay.
Get your nose out of your book. Anybody remember what inductive reasoning was? Okay. It's when you make an educated guess based on past experience. Okay, is predicting the future. So, you guys remember that assignment we had? It was like 1, 4, and there were some pictures, and we had to like predict what the next numbers were. That's inductive reasoning. Because we don't know what the pattern is, but we're assuming it's like +3 or something. So that's inductive reasoning. Deductive reasoning is like, I know this rule, therefore this has to happen. Okay, it's like, all fish have scales, a piranha is a fish, therefore a piranha has scales. That's like, this is the rule, this is the rule, this is the conclusion. Anyways, that's deductive reasoning. It has to be true if the assumptions are true. Okay, number 1, after surveying thousands of individuals, The Gallup poll predicted the winner of the presidential campaign. Is that inductive or deductive reasoning? Right. Is a poll always gonna be right, like 100%? No. A couple elections ago, Donald Trump was not supposed to win. For some reason, the polling was wrong. It's usually right. Usually it does predict the winner, but so it's just based on a few of the people. Now, if they polled everybody, that would be a pretty good predictor. But if you're just basing it on a few people, that's just inductive reasoning. We're not for sure, but probably. Number 3, in a civil suit, no witnesses testified unfavorably concerning the reliability of the defendant. So the testimony of the defendant was accepted by the jury. So if a few people say you're good, you're reliable, do we know for sure or not? Not for sure, just from what they've seen. So if it's not a for sure thing, then it's inductive. Okay, number 5. Two lines intersect. Every line contains at least 2 points. 3 distinct non-collinear points lie in exactly one plane. Therefore, 2 intersecting lines are in exactly one plane. Okay, that's deductive. They're like, this is the rule, this is the rule, this is the rule, so this is what has to be. So, that's deductive reasoning. Okay, number 7. So the options are in the direction that says modus ponens, modus tollens, or transitivity. Those are the 3 options. So number 7, if A then B, if B then C, A then B, B then C, therefore, A then C, what was that one? Transitivity, because remember the train? A is connected to B, B is connected to C. So anyway, transitivity. Number 9. Okay, if A then B, not B, therefore not A. What was that one called? Okay, this was the more complicated of the 2. If not this happens, then this couldn't have happened. So it's kind of like the contrapositive. Not this, then not this. So this is called modus tollens. Remember I said it's kind of in alphabetical order. The more complex one, modus tollens, T comes after P, the more complex comes after the simpler. Okay, now 11 is actual words. Number 11, if I break my arm, so we're still saying what kind of logic is this, like one of those 3. If I break my arm, then I will go to the hospital. I broke my arm, I'm going to the hospital. What is that logic? Yes, that's like the basic. You're kind of restating the conditional statement. Modus ponens. If I break my arm, I'm going to the hospital. I broke my arm, I'm going to the hospital. You're just kind of following that conditional statement. Very basic. All right, 13. A good definition is reversible. John's definition of parallel lines was good. Therefore, his definition was reversible. Yeah. Yep, ponens again, yeah. So it said, If it's a good definition, it's reversible. So that's like good definition, reversible. Then it said John's definition is good, therefore John's definition is reversible. So it's just kind of restating the same thing. It is, yes, you're right. It is modus ponens again. Okay, 15, if you study for a geometry test, you'll get a high score on the test. If you get a high score on the test, then you will get a good grade on your report card. Therefore, if you study for the geometry test, you'll get a good grade on the report card. Right. Studying gets you a good high score. High score gets you a good grade on the report. So therefore, studying gets you a high grade on the report card. That is the connected one, that's transitivity. Okay, on the last section, we have to state the conclusion ourselves for each set of premises. And then state what kind of logic we use to get there. Okay, 17, if a triangle has two congruent sides, then the triangle is an isosceles triangle. Triangle ABC is not an isosceles triangle, therefore, right, if it's not isosceles, it can't have two congruent sides. Let's see, triangle, oops, I don't need that word because I can just use a symbol, sorry. Triangle ABC does not have two congruent sides. Okay, what logic did we use to get there? So they said if it has two congruent sides, it's isosceles. Then they said this triangle is not isosceles, therefore it doesn't have modus. It's the more complex one. It's not B, therefore not A. So it's modus tollens. Not the second part and not the first part. That's modus tollens. All right. 19. If you are running, then you are exercising. If you're exercising, you're burning calories. Therefore,
Who's burning calories you're running?
no. Somebody different. Okay,
Say it again.
if you're running, I just read the problem. If you're running, then you're exercising. If you're exercising, you're burning calories. Therefore, what?
Transitivity.
Well, we need the conclusion. Okay.
If you're running, you're burning calories.
Yeah. Yeah. If you're running, you're exercising. When you're exercising, you're burning calories. Therefore, when you're running, you're burning calories. If you are running, what's transitivity? If A, then B, if B, then C, therefore if A, then C. All right, 21.
I understand.
A concise definition avoids unnecessary words. So if it's concise, it avoids unnecessary words. Your definition is concise, therefore, what? Your definition avoids unnecessary words. Yeah, that's the basic one, you're kind of restating if A then B, A, therefore B. So that's the basic one, modus